So these will be the notes for section 9.3 rotations. By the end of this, we should be able to meet these two objectives. I will be able to draw rotated images using the angle of rotation, and I will be able to identify figures with rotational symmetry and point symmetry. First off, let's get started with what a rotation is. It's a transformation that maps every point of a pre-image, remember that's our original shape, through a specified angle and center of rotation about a point. So the best way I think to see an angle and center of rotation is to do a couple of examples. So the examples we're going to do here are problems 1 and 2, or examples 1 and 2. It says to rotate each figure, and we're going to rotate it about a point each time. So what I did to make things a little bit easier is I took this picture right here, I copied it over, and I did my best to put P in the center. P won't exactly be in the center, but that's where I'm going to rotate it. So for number 1, I'm told to rotate it 90 degrees clockwise. So hopefully everybody knows this, but in case you don't, this is clockwise. So remember, that's the way the clock moves. And this is going to be counterclockwise. So number 1 says 90 degrees clockwise. So I take this, point P is in my center. So point P is in the center. And I rotate it. So like I said, point P is not going to be perfect. As you can see, it's not the same exact spot. But anyways, this right here is my image. So whenever I move it back over, I see that the original shape is my pre-image. Whenever you're doing this on your paper, make sure to physically turn your paper 90 degrees and you'll get the right answer every time. If you can't do it where P, you want point P to be on the edge of your paper whenever you do this, and that way you'll be able to get every time. So we're still struggling to see it. Let's do the same thing again with number 2. This is my pre-image. And this one says to rotate it 180 degrees counterclockwise about point R. So again, point R is my center. And whenever I highlight this, you see that I tried to put point R in the center. And again, I'm a little bit off. But 180 degrees around will make my image right here. So that's my image. So again, I have my pre-image there, and my image is flipped around just like that. Which gives you a good idea of what to do for these rotations. We also have examples where we use the coordinate plane. This is probably going to be more important. This is more likely what you're going to see on your test, SOL, and things of that nature. So what I've done on the next page is I've already graphed the points that you need to plot. So what I have is A, B, C, and D. So I'm going to rotate this now. And whenever I rotate it, let me copy that over. I have these points. So these points here become A prime, B prime, C prime, and D prime. So whenever I flip it back over, I see that A prime has the coordinates -1, +2, so I'm just getting A prime from right there. B prime is 1, 5. C prime is 5, 4, and D prime is 3, 1. So the strategy you want to do is to first write down these points, and then whenever you rotate it back over, so whenever we're back at this one on the left, then we can actually plot the points. So we would have -1, +2, this would be A prime. 1, +5 is B prime. C prime is 5, 4, and D prime is 2, 1. So those are going to be, that's going to be the quadrilateral rotated 90 degrees clockwise. Again, it's all about just rotating your paper to represent it. Let's do example number 4. So again, I've copied down example 4. It says we're going to rotate it 180 degrees counterclockwise. So that means we're going to shift it 180 degrees, or we're going to turn it halfway over, one half of a rotation. So I see what my points are. That point right there is going to be -2, 3. This point right here is going to be -4, 0. This green point here is going to be -3, -5. And lastly, we have this blue point, which is going to be 3, -3. So I did my best to put everything in the center, so the origin in the center. And because I did a pretty good job, I see my points are already mapped perfectly. So the way the shape will look will be just like this. That is a rotation of 180 degrees about the origin. So remember, the origin, the center point, is right in the center, 0, 0. So number 5 is one that you should do on your own. You've had a couple of examples to work off of, so hopefully it'll make sense. So that's pretty much all we have on rotations, and now we have rotational symmetry. So we talked about line symmetry before. That's where you had an object and you can fold it in half and you'd end up with the same object. So we have the definition there. We also have this concept of order. It's the number of times a figure can be rotated onto itself, including 0 degrees, but not 360 degrees. So everything has an order of 1. Now, we could take these shapes and rotate them, but I'm going to tell you that they have an order of 2, sorry. So this shape here has an order of 2, this one has an order of 5. So if I flipped it 180 degrees, that's the magnitude, 360 divided by 2, so 360 divided by the order was 2. That's the magnitude of this shape. The second one, it has an order of 5. So that means every time I rotate it 72 degrees, it's going to repeat itself. You're going to have the same shape again. Point symmetry is whenever we rotate it 180 degrees, do we have the same shape? For this first shape, the quadrilateral, the answer is yes, we do have point symmetry. For the pentagon, it's no. So point symmetry is a special type of rotational symmetry. So we have examples 6 and 7 to give you a better idea of how to do this. So right away, we know that every shape has a minimum in order of 1. Let's see if we have any more times we will repeat this. So I'm going to be rotating the one on the right, and I want to see how often it's going to be the same shape as the one on the left. So right away, there's another time it repeats itself, so we're at order 2. So it looks like we've repeated ourselves right about there. Order 3. And then it won't repeat itself again until we're back at the start. So it has an order of 3. So the magnitude is going to be 360 divided by 3, which is 120. That means every time I rotate 120 degrees, it's going to repeat itself. Lastly, does this have point symmetry? Is it the same shape when I turn it upside down? The answer to that is no. So there is no point symmetry. Let's do that same test again for this object that looks like a kite. We see that we never have the same shape until we come all the way around. So that means the order is 1. The magnitude is 360 divided by 1, which is 360. And point symmetry, again, is where I flip it upside down. It's not the same shape, so there is no point symmetry. So moving on to the last page of our notes, I want to do example number 9 with the regular hexagon. So again, we're going to do that same test. And this might be a little bit difficult to see, but I see if I turn it over. So right away, the order is automatically 1. It's going to be at least 1. And I see right here I have the same shape, so we're at 2. So I keep turning it. We're at 3. Keep turning it. 4. And right now it's upside down. Do you see how it's the same shape? That means there is point symmetry. So if I keep turning it, there's number 5. And there's number 6. And then it doesn't repeat itself until I'm back at the start. So the order is 6. The magnitude is going to be 360 divided by the order, which is 6. So our magnitude is 60. So every time I rotate 60 degrees, I'm going to be back at the same shape. There's a few other examples I'd like you to do on your own, number 8, 10, and 11. Just keep turning your paper over and seeing how often it repeats itself. For regular objects, like the regular hexagon, for regular polygons, I should say, there will be however many sides there are. So the hexagon has 6 sides, so that's going to be its order. The order will be equal to the number of sides. So the last type of example we have here is numbers 12 through 17. We're asked to rotate things differently. So what you need to remember is that this is an octagon, and it's going to have all of these congruent triangles. So all of these triangles are going to be the same. So what is each angle inside here? Since there's 8 sides, it's going to be 360 divided by 8, which is 45 degrees. So that means each time I move over, it's going to be 45 degrees. So on and so forth. So if I start at point B, and I'm asked what it's going to be when we do a clockwise rotation. So if I take point B and I rotate it 135 degrees, that's going to be like 4 turns. Sorry, 3 turns. So we're right there. So this is where B is. Therefore, E needs to be the answer to number 12. So B will get changed into E. We can do the same thing with all of these shapes, or sorry, with all the letters. Or we can just kind of count. That'd probably be the easiest way to go. So if I want to go 90 degrees from F, counterclockwise, E would be 45, D would be 90. So D would be the correct answer. That's how I recommend you do these, but if you're a much more visual learner, perhaps you can spin things around. It would help you out. Now for 14 and 15, I'm looking for the pre-image. So that means I would go the opposite direction. So when it says counterclockwise, I'm really going 180 degrees clockwise from C. So if I go clockwise, this would be 45, 90, 135, 180. So G would be the correct answer there. Remember, 180 degrees is on the complete opposite side too. A 45-degree clockwise rotation would be a 45-degree counterclockwise. So it'd be H. Remember, when we're looking for the pre-image, we move in the opposite direction. So pre-image moves in the opposite direction. So we can also do this with segments. If I look at GH, remember we go G to H, and I do a 270-degree counterclockwise. So where does GH go to? GH becomes AB. That's the same position. So we're going to have segment AB here. And just to check yourself, a 90-degree counterclockwise from BC would be a 90 degrees. So if we have BC, AB would be 45 and HA would be 90. So hopefully all of this made sense. Please feel free to ask me any questions and have a great day.